Welcome to Now in Android, a practical guide to Android design principles. In this series, we'll use Now in Android to delve into the best practices of Android development. In this video, we'll learn about the concept of test doubles in testing. A test double provides a test-specific dependency. One type of test double, a fake, is a test double that has an implementation that behaves like a real class. A mock is a test double that behaves as programmed for testing and has expectations for interactions. Mocks are created using mock frameworks. On the other hand, if it doesn't have expectations for interactions, it's called a stub. There are other types of test doubles as well. Please refer to the references if you want to learn about other types. Official documentation and Now in Android recommend using fakes instead of mocks in tests. Next, I will explain why we use test doubles. The official documentation cites two reasons for using test doubles. The first reason is that it can shorten the execution time of tests. For example, if you use the actual network without using test doubles, the execution time of a single test will become longer. This makes it difficult to get quick feedback. The second reason is that it can simplify tests. If you don't use test doubles, you may need a lot of code to prepare the preconditions. This reduces the maintainability of the tests and makes it difficult to understand which part you are testing. Okay, let's take a look at the test double policy in Now in Android. In Now in Android, two test doubles are provided for the interfaces of the data layer. The first is a fake repository implemented in the data test module. This repository behaves like a real repository while eliminating network dependencies. In the test code, this fake repository is injected by DatterHelt. The second is a test repository. The test repository has test-specific functions and provides an implementation of the interface that takes those functions into account. The test repository is mainly used for unit testing of view models. This repository is generated within the unit test and injected into the class under test through the constructor. Okay, let's take a look at the actual code. First, here's the implementation for the topic repository interface. The offline first topic repository is injected by DatterHelt in the production code. In the sync with function, topics fetched from the network are saved to the database. In the getTopics function, the list of topics saved in the database is returned. Here's the English translation of the Japanese text. Next is the fake topic repository. The sync with function in this class always returns true, indicating synchronization is complete because it doesn't use the network. The getTopics function obtains and returns values from the daemonian network data source. This data source reads a pre-prepared JSON file and returns that data. Therefore, this repository doesn't depend on the network, and it's structured so that topics can always be retrieved from a local file. Also, note that the dispatcher is present in the constructor argument. Due to the DatterHelt configuration for testing, an unconfined test dispatcher is injected into this dispatcher. Finally, we have the test topic repository. This repository provides the sendTopics function. By using this function, you can set the values returned by the getTopics function. Because the function specifies the return values, the sync with function will always return true, and there is no network dependency.